Good evening, everyone, and welcome to Codesmith's speaker series. It is absolutely brilliant to see so many familiar faces. Hello, my name is Marae. I'm an engineering mentor for Codesmith's New York on-site campus, and I'm here to introduce the main event, of course. James Laff is an engineering mentor for Codesmith's East Coast Remote Immersive, and not only that, he is also the founder of Svelte Society Philadelphia, another fine feather in his cap. And he is here to share his passion and expertise on, you guessed it, Svelte. So without further delay, I'm going to pass it over to you, James.
Fantastic. Thank you, Marae, for the introduction, and thank you all for coming. I copied a few links into the chat just so you have those available. And I will be talking about Svelte, D3, and the what you see is what you get future of web development and data visualization. As an open source contributor, I work to make web development more inclusive and creative. Svelte is a great means to that end, but its ecosystem of supporting libraries is relatively limited. So I helped build a data visualization library, Svender, to facilitate the integration of Svelte with D3. My roadmap for this evening is to introduce you to Svelte, highlight its advantages for data viz, and explain how and why Svender came to be. Now, back in the dark ages, the 1990s, we didn't build web applications. We designed websites. Content was mostly static. You couldn't even Google anything. Bandwidth was so limited that downloading a movie took literally days. Now, from the late 1990s through the 2000s, web pages gradually became more interactive, thanks in large part to JavaScript. But when did websites become web applications? The simplest type of interactivity involved navigation. Rather than clicking on a link to load a different page, new content loaded without changing the URL in your address bar. Over time, more and more interactivity moved into the code that ran on the user's computer. This ultimately became the single-page application. The idea was that content would load in one place, maybe inside a layout that didn't need to reload, hopefully faster than if you had to actually navigate to a new address. In other words, the experience became more like using an application on your computer. One of the major challenges to this brave new world of web apps was the developer experience. With vanilla JavaScript, that is plain JavaScript without any libraries, you have to specify how each HTML element or CSS style needs to be manipulated using the document object model or DOM. Now, this vanilla approach doesn't scale well for the developer or typically the user, because even fairly common operations like adding an item to a shopping cart have a lot of moving parts. Sending an event to the backend, updating the number of items in the cart, changing the add to cart button to a remove from cart button, binding and unbinding event handlers, and so on. And the more precise your DOM manipulation gets, the more extensive your code needs to be. In addition to the tediousness of keeping track of any changes to the DOM, vanilla JavaScript also suffers from repetitiveness. Every bit of the UI needs to be handled separately, and the functionality associated with it is difficult to disentangle from the UI itself. And not only does this generate additional work, more code invites more mistakes. And every time you change one of those repeated code snippets, you have to manually update all the others. Enter front-end frameworks. Now, React wasn't the first framework, but it established a paradigm that changed the way we think about web development. This paradigm shift was made up of two parts that directly addressed the challenges of vanilla JavaScript: state and components. Rather than treating dynamism as an afterthought, React bundled all dynamic aspects together in one concept: state. React also harnessed modularity, a way of dividing and organizing code into components such that it could be more easily reused and maintained. In some ways, React was one step forward and two steps back. In order to manage dynamic elements, React introduced the virtual DOM. The virtual DOM generates an image of what the DOM should look like and compares it to what the DOM currently looks like, a process they call diffing. Now, they maintain that virtual DOM diffing is much more efficient than removing everything from the DOM and rebuilding it from scratch every time something changes. Well, this, of course, is true, but it's a straw man argument. No one actually removed everything from the DOM and rebuilt it from scratch in production, or suggested that you should. Because the diffing process takes place on the client's machine, all of the code necessary to perform this diffing has to ship along with the application. This is a significant amount of bloat. Of course, there are ways to mitigate this: minification, code splitting, prefetching, service workers, lazy loading, etc. But keep in mind that various methods of reducing the bloat that users have to download have no impact on the amount of bloat their computers need to run. This is one of the downsides of using React. In order to use it correctly, you need to incorporate a lot of third-party tools. For that matter, there are also a lot of internal React features that are not necessary for an app to function, but are necessary for an app to function well. The fundamental problem is that React is not fully reactive. When something changes based on a fetch request, a user input, and so on, React doesn't know what needs to change as a result. Instead, it compares the way things are to the way things should be and changes whatever differs between those two. Wouldn't it make more sense to keep track of what needs to change and directly update the DOM accordingly? Svelte to the rescue. Now, unlike React, Svelte is a compiler. So instead of shipping your JavaScript along with a library that tells the client how to render and re-render your code, Svelte builds the necessary instructions into a compiled version of your code. Rather than placing the burden of figuring out what to re-render on the client's machine at runtime, Svelte lets the developer map out the re-rendering process when writing the app, and this process is codified at build time. The other major difference between React and Svelte is that Svelte compiles JavaScript topologically, meaning it knows the order in which reactive variables depend upon one another. As a result, Svelte doesn't need a virtual DOM or any sort of diffing. It surgically updates the DOM when the state of your app changes. This improves performance, reduces bundle size, and enhances code readability. Time for more history. This time, compliments of Svelte's creator, Rich Harris, from his 2019 Rethinking Reactivity talk. In 1969, Laff introduced spreadsheets with forward referencing and natural order sorting, or what we now refer to as reactive programming. The idea is that values in one cell or column or row can depend upon values in another, such that when those values change, the dependent values update accordingly in order. As a simple example, think of the columns price, quantity, and total, where total is calculated by a formula that multiplies the corresponding cells in the first two columns, a sum total cell in the top left corner. Now, forward referencing means that the spreadsheet would know the order in which the updates need to occur. So first, the total column, then the sum total cell. Laff did not succeed, however, and in 1979, WYSIWYG debuted. WYSIWYG's approach was much simpler and less efficient. Instead of forward referencing, it simply scanned the spreadsheet from top to bottom, left to right, and recalculated every cell containing a formula. Even worse, it only recalculated values once. Now, if your dependencies required multiple passes to recalculate completely, you had to trigger each recalculation manually. So their recommendation was that you lay out your spreadsheet in such a way that such recalculations wouldn't be necessary. In fact, they insisted that forward references were the result of hasty or careless work. The WYSIWYG was so successful that it's often considered the first killer app. Consumers bought Apple II computers just to run it. But in 1983, Lotus 123 revived forward referencing and proved just as valuable in encouraging purchases of IBM PCs. You may have guessed by now what Rich was getting at when he told this story. React's approach strongly resembles VisiCalc's, while Svelte emulates LandPAR. And don't get me wrong, there's a lot to like about React. It changed the game, and web development has been vastly better because of it. But React is fundamentally flawed, and it's become a victim of its own success. They, and by they I mean Meta, whose engineers developed and maintain React, cannot completely overhaul React or introduce anywhere near the number of breaking changes that would be necessary to change React's fundamental approach to reactivity, because too many companies rely on React. In the nearly 10 years since React was publicly introduced, they've released numerous features intended to mitigate React's fundamental flaw. These have certainly helped, but they haven't closed the performance gap with Svelte, and it's hard to imagine that they ever will. Rich invented Svelte in 2016 while working as an interactive editor at The Guardian. Given his background in journalism, it's no surprise that one of the most popular ways to use Svelte is for data viz. Rich's former team at The Guardian uses it, so does the New York Times graphics department, where he worked as a graphics editor until late last year, when he took a job at Vercel to work on Svelte full-time. Now, one of the most powerful and widely used data viz libraries is D3, Data-Driven Documents. Incidentally, D3's creator, Mike Bostock, also worked as a graphics editor for the New York Times. Clearly, something in the New York water makes for great pizza, great bagels, and great JavaScript innovation. D3 provides incredible tools for translating information from the data space to the pixel space, but it has a notoriously steep learning curve. D3 is divided into modules, many of which are only used to produce specific types of data visualizations. D3 is designed with the expectation that whichever modules you use to generate a visualization, you will use D3 selection to render it to the DOM. This presents a structural problem for React. Because of the virtual DOM diffing process, React cannot yield control of the DOM to D3 without some additional mechanism to enable React to stay in sync with re-renderings. To facilitate cooperation between the two, a number of excellent D3-based charting libraries have been developed for React, including Recharts, Nevo, and Victory. In addition to making it possible for D3 to function with React, these libraries clearly demonstrate the appeal of a simplified developer experience around data viz. Svelte doesn't suffer from the same disadvantage. It's entirely possible to render pure D3 in a Svelte app. Even so, there are great reasons to transfer control of the DOM from D3 to Svelte. Perhaps the best reason is performance. As well as D3 handles DOM manipulation, Svelte optimizes it even further by virtue of its compilation process. Also very important is reusability. Svelte DataViz components can easily be reused within and across applications. One of the great benefits of Svelte is that it unifies markup, styling, and JavaScript in a single componentized file. Styles are scoped by default, alleviating a common pain point of CSS. This approach to organizing code is one of many lessons learned from other frameworks over the years that Svelte has seamlessly incorporated. So how should Svelte and D3 work together? Certain D3 methods or modules generate chart elements, and Svelte conditionally renders them using logic blocks. This takes the best of both worlds: D3's ability to manipulate data and organize it into a visual form, together with Svelte's ability to render visual data to the DOM, including transitions and animations. In addition to taking advantage of Svelte's performance optimization relative to D3, moving DOM-related code into Svelte dramatically enhances readability. As I'll demonstrate later on, D3 is incredibly imperative and uses highly esoteric syntax. It takes a significant amount of time to become comfortable with D3's API. But web development and data viz are often collaborative endeavors. And the more that people working on the project are able to understand what the code is doing, the better able they'll be to contribute. This is one of the best things about using Svelte, not only compared to D3, but also to React and other front-end frameworks. It strives to be as intuitive as possible by keeping your code very nearly within the approachable domains of JavaScript, HTML, and CSS. Svelte's efficiency makes for a great user experience, while its readability makes for a great developer experience. These are undoubtedly among the top reasons why developers love Svelte. Indeed, it consistently ranks at the top among front-end JavaScript frameworks in developer surveys. It doesn't help that Svelte is extremely easy to learn, especially if you're already familiar with JavaScript. You can get through the tutorial and build a simple application in only 1 to 2 hours. Another reason developers love Svelte is that it works incredibly well out of the box. Unlike React, you don't need to worry as much about implementation to make your app performant. Now, for complicated visualizations or applications in which the visualizations are fully interactive and integral to the app's flow and navigation, the best option is to use Svelte and D3 in the way that I've described. But there are also much simpler use cases, when all you need is a chart, and you don't want to climb the D3 mountain in order to drop one into your application. Now, there are some great resources for building your own charts, including Pancake from Rich Harris and Layer Cake from his former colleague Michael Keller, but nothing interactive or what you see is what you get. React has an extensive ecosystem of third-party libraries. Whether you need a streamlined visual interface like Material UI or robust state management like Redux, you can find a great tool to facilitate your development process. But React shouldn't have all the nice things. The Svelte community is growing at an astounding rate. One of the most significant obstacles to Svelte's adoption is that it lacks an extensive ecosystem of quality tooling. With Svender, my team built a tool to fill that void with an interactive WYSIWYG data viz library for Svelte. Which should be playing, but isn't. So maybe I will close this and restart it and see if it will present properly. There we go. My team built a tool to fill that void with an interactive WYSIWYG data viz library for Svelte. First, you customize a chart by updating adjustable properties. You can see the chart and code update in real time in the interactive application. Then you copy the code directly into your Svelte component. Next, you format your data according to the schema Svender provides. And that's it. Svender functions like a wrapper around D3. Rather than trying to replace D3 modules, it incorporates them into plug-and-play visualizations. The easiest way to customize a chart is to see how each parameter affects its presentation. And that's exactly what Svender provides. Take, for example, the area chart. This chart offers 21 customizable properties, including margins, axis labels, grid line visibility, colors, opacity, and more. There's always a balancing act when designing a tool like this. It should be robust enough to be useful for many applications, but not so complicated that users might as well use the tools it's meant to abstract away. Svender allows users to customize as many properties as possible without requiring unintuitive interaction with D3. Essentially, Svender takes all of the parameters exposed by D3's API and makes them interactive. Some properties are fairly common across charts: colors, size, stroke, opacity, and tooltips. But others are highly particular to each chart. The chord diagram, for example, includes properties pertaining to the band around the perimeter. The ridgeline plot allows you to specify the extent of the overlap between each ridgeline. The radial stacked bar chart lets you choose whether to sort the values. The Svelte REPL is an excellent playground to test Svelte code. One of the really neat things about it is that you can see how Svelte compiles your code by looking at the JS output, CSS output, and AST, abstract syntax tree, output tabs. You can even adjust compiler options. For example, you can choose to generate client or server-side rendered code. In our case, it's a perfect place to demonstrate how straightforward the developer experience of Svender is. All we have to do is paste in the data and customize chart code. Before I dive into technical challenges, I want to point out that some things that would ordinarily pose technical challenges, like transitions and animations, didn't, because Svelte includes these features out of the box. Take Svender's bar chart, for example. The user is able to sort the data by ascending or descending frequency, or by its original default order. In order to make the change from one sorting to another feel more realistic, it helps to apply an animation effect rather than just snapping from one to the other. In Svelte, anytime you're changing the positions of elements already on the DOM, you'll want to turn to the animate module. There are a number of parameters you can use to customize the flip animation effect, but in this case, the only one we need is duration, which is set to 1 second. Because Svelte works as a compiler, it only includes the code to render this animation if you're using it. This is part of the reason Svelte can include a feature like this that you'd need a third-party library to implement in React. If you want an effect when adding or removing elements from the DOM, you'll want to use the transition module. Transitions in Svelte are just as straightforward as animations. Let's say we want the tooltip for the line chart to fade in and out. All we need to do is import fade from the transition module and apply it to the tooltip div. You can always plug and play with Svender charts, but if you do want to add further customization, it's much easier because all the DOM manipulation is now handled by Svelte instead of D3. There were a number of interesting technical challenges in the course of developing Svender. The most interesting of these were accessibility, unpacking D3, reactive stores, and prefetching. My goal in describing these challenges and solutions is to give you a sense of some of the things that Svelte can do and how you would accomplish these sorts of things. Svelte strives to make web apps accessible by default. This is an extremely important and too often overlooked aspect of web development. Part of the challenge for developers is that disabilities can involve mobility, cognition, vision, hearing, speech, or a combination thereof. The World Wide Web Consortium developed the Web Content Accessibility Guidelines, which specify 3 levels of accessibility compliance for web content. These guidelines provide incredibly detailed suggestions for how each type of information should be presented. Broadly speaking, they specify that content should be perceivable, operable, understandable, and robust, meaning interpretable by a wide variety of user agents. Software engineering is severely lacking when it comes to diversity. This is certainly true in terms of disability, and it's not intuitive for developers to accommodate challenges they themselves don't face. People with physical disabilities, for example, can struggle to fill out forms within preset time limits, or navigate sites without full keyboard support. When so few developers understand how people with disabilities experience their applications, it is unfortunately unsurprising that of homepages for the top 1 million websites, 97% fail to meet accessibility standards. And this number has been consistent since they started testing in 2019. The most obvious impediments to experiencing the web involve vision impairment, including full, partial, and color blindness. Indeed, the most common accessibility failures all impact people with vision disabilities. low contrast text, missing alternative text for images, empty links, missing form input labels, empty buttons, and missing document language. Incidentally, 97% of the issues found fall into one of those categories. All of these issues, except low contrast text, have direct implications for how well screen readers are able to translate content. Because Svelte is a compiler, it's able to identify and warn you about some of the most common accessibility pitfalls. Does Svelte guarantee accessible applications? Absolutely not. Automated tools are only capable of finding 20 to 30% of accessibility issues, and Svelte only accounts for a subset of what can be tested. Ultimately, the best way to ensure that your application is accessible is to have users with disabilities test it manually. Even so, Svelte's accessibility warnings address, at present, half of the most common issues: missing alternative text, empty links, and missing document language. Given the prevalence of these issues and the difficulty they pose to screen reader users, it is an extraordinarily important achievement for Svelte to highlight them in the developer's console. As you might expect, accessibility is even more challenging when it comes to data viz. Too often, screen readers are unable to capture any information from visualizations. In the most egregious examples, all of the important information on a page is wrapped into a visualization, and the only thing a screen reader can convey is image. By default, D3 does not make any accommodations for accessibility. Google Charts, on the other hand, provides a hidden accessibility table, visible only to screen readers, that provides access to the corresponding data. This simple gesture makes an extraordinary difference. For screen reader users, the accuracy of extracted information when using Google Charts is 73%, compared to 17% with D3. But providing raw data is only the beginning of what data viz libraries should offer in the way of accessibility. It should be possible for the user to navigate through data points using their keyboard, with tooltips to provide detail about each point. Keyboard navigation is always a great start for screen readers. Developers should be prompted to describe the visualization, just as alt text describes images. Any text should follow the same accessibility principles governing text throughout the page, including readability and responsiveness. Color schemes should account for color blindness, and colors should only complement what is already apparent. As with accessibility in general, it is extremely difficult to build a library that accounts for all of these considerations. At a certain point, the best we can do is point developers in the right direction and trust that they will take on the responsibility of inclusive design. But pointing developers in the right direction, helping them make good choices, is a reasonable expectation for the tools we build. Svender's goal is to incorporate as many accessibility best practices as possible. For example, most Svender charts can be navigated entirely by keyboard, with information provided by each data point. Those that aren't yet will be by Svender's stable release. In this respect, the goal is not only to make D3 more approachable, the goal is actually to make D3 more responsible. D3 is built on the assumption that it will directly manipulate the DOM. Most of this functionality is contained within the D3 selection module, which includes many methods that mimic JavaScript's own DOM manipulation methods. Standard D3 approach is to generate each component or layer or aspect of a visualization in the order they need to be applied to the DOM. But the way in which it breaks visualizations into discrete tasks is far less intuitive than Svelte HTML. Formally, we'd say that D3 is more imperative. Your code describes how its goal is accomplished, whereas Svelte is more declarative. Your code describes what its goal is. And wouldn't we all prefer to tell computers what to do and just let them figure out how to do it? The challenge for Svender was to capitalize on the useful methods from D3 while leaving its tedious approach to DOM manipulation behind. In some cases, these adaptations are straightforward. For example, this D3 code simply becomes this HTML code in a Svelte component. This example is a great illustration of D3's imperative approach in comparison to HTML. The only Svelte-specific code here is width and height in curly brackets in blue. For those of you who are familiar with other front-end frameworks, this looks suspiciously like JSX, but cleaner. Because in Svelte, when the attribute name and value match, in other words, width is equal to the variable width, you only need to provide the name, width. Otherwise, this example is pretty self-explanatory. You can see how both code snippets create the same SVG element with the same properties. You can also see how Svelte's HTML is more declarative. We simply define the element with its attributes in line, rather than specifying and applying each one separately with a D3 method. Other cases are slightly more complex. For example, this D3 code becomes this Svelte HTML. Here, we see a Svelte logic block using each, which allows us to loop over a list of data, in this case, an array of wedges in a pie chart. The D attribute of a path element defines the path's shape. But don't confuse this with the D that is used by convention in D3 to represent a given element of data. Wedge path is a manually defined function that generates the path for each wedge of the pie using D3 methods. Because Svelte gives us access to each element in the wedges array, as well as its index I, we can easily select the appropriate color for each wedge from our colors array without an intermediary color function. It's much easier to see what the Svelte example does. For each wedge, create a path element of corresponding color and a derived shape. This simplicity is not a coincidence, nor is it a pleasant side effect of Svelte's structure. Simplicity is at the core of Svelte's design, both in terms of what happens under the hood in the compiled code and in terms of what the developer sees. Some of you have never seen Svelte code before, but I'll bet you can look at this snippet and make remarkably accurate guesses about how it works based solely on your intuition. The same cannot be said of D3. This is valuable even for experienced developers. The clearer your code is, the less likely you are to make mistakes, and the more likely you are to catch them. Perhaps even more significantly, the less code you write, the less likely it is to contain bugs. And the less code you ship, the faster it can run. In some cases, the translation from D3 to Svelte is quite complicated. This D3 code becomes this Svelte HTML. Now, there's a lot we could unpack in this circle packing bubble chart, but I'd like to focus on the T-span subtext. In Svelte, it's relatively clear what's happening here. We have an each block nested inside an each block. For each leaf, we render subtexts from an array that we derive using split. In D3, the nesting of data is not apparent. Also, you have to follow lowercase d and uppercase d to understand how the subtext array is being derived and when it's being referenced. I'm not claiming that this Svelte code is 100% intuitive, just that it's far more declarative than its D3 counterpart. As you can hopefully start to get a sense from these examples, there is ultimately a kind of simplicity in this method of Svelteifying a D3 visualization. Once you get the hang of D3, its methods and conventions, transferring DOM manipulation to Svelte is relatively straightforward. But as I said before, D3 has a steep learning curve. One of Svender's goals is to become a hub for the Svelte community to share DataViz components. If you're familiar with Observable, the idea is a similar Svelte-specific platform. Particularly with this goal in mind, it's important that the developer workflow for adding new visualizations to the interactive application is as streamlined as possible. In order to add a chart to the application, you need to have, one, the standalone code that renders the chart, with each customizable property converted into a reactive variable, a JSON file with all of the information necessary to display the chart in Svender, and dummy data. Svelte takes advantage of the rarely used JavaScript label to identify reactive statements. Specifically, you preface each reactive statement with $::. This reactive label can be applied to variable declarations and reassignments, of course, but also to functions, loops, etc. In Svender, it's therefore necessary to distinguish statements that need to be reactive in the standalone component from statements that only need to be reactive in Svender. This is accomplished simply by starting whatever variable or function name follows the label with the word reactive. Not the most original approach, perhaps, but certainly clear. The purpose of a store in Svelte is to manage state that needs to be accessible to a number of unrelated components in an application. To keep the workflow simple and the app performant, the best approach for Svender was to have only one reactive store shared by all of the data visualizations. The alternative, creating a new store for each chart, would have required changes to the core application code when adding a new chart, which would have made the process more cumbersome, especially for non-core contributors. The way this works is that Svender initializes a writable store, chart docs, as an empty array. When a chart loads, chart docs is reset to an empty array, and the chart's properties are written to chart docs using the update method. This process of clearing and repopulating the chart docs store worked perfectly well until Svender tried to implement prefetching. Now, to explain the issue, I have to briefly introduce SvelteKit. In essence, Kit allows you to build a full-stack Svelte application. It handles routing, how users navigate around your application, page layout, aspects of pages that remain visible across your application, and data loading, how, when, and where your application code runs. Each of these features is very complicated, which is why Kit was still in beta until just last week, when Rich announced at Svelte Summit that it's officially a release candidate. SvelteKit is a thoroughly modern, high-performance framework with blazingly fast hot module reloading using Vite, code splitting, prefetching, configurable rendering, server-side with client-side hydration, service workers, and seamless serverless integration. Prefetching is one of its best features, and for Svender, it was the hardest to implement. The idea behind prefetching is simple. Rather than waiting to import or download code until the user loads a page, Kit will prefetch it when the user hovers over or touches the link to that page. It may not seem like prefetching would make such a big difference, but it does. How much time it saves depends, of course, on how long a user hovers over a link before clicking on it. But you can reliably count on saving at least a couple hundred milliseconds, which can be enough to make your app seem responsive instead of laggy. As an example, by implementing prefetching, Netflix was able to reduce the time users have to wait before being able to interact with the application by 30%. The challenge for Svender involved the interaction between prefetching and the reactive store. As you navigate from chart to chart, the basic framework, chart, code, schema, data, and properties, stays the same. Each chart has its own data and image that get plugged in. Prefetching the code, schema, data, and chart component doesn't cause any problem. Those can be downloaded to the user's machine so they're ready to go. But importing the new properties into the chart docs store must wait until the user clicks the link. Otherwise, the current page breaks. The current properties would still be displayed in the properties section, but the new properties would have been loaded into the store. So all of the property references would break and the customizability would fall apart. This wasn't a problem until prefetching entered the picture because the rendering processes could be ordered in such a way that the store was populated before the other components were rendered. At the time, the best solution was to take advantage of Svelte's lifecycle methods. Svelte provides 4 lifecycle methods: on mount, before update, after update, and on destroy, plus a wildcard tick, which we won't go into. And broadly speaking, 3 of these mirror React's most common lifecycle methods. On mount is like component did mount, On destroy is like component will unmount, and after update is like component did update. However, in this case, all three of those lifecycle methods would come too late to update the reactive store. New properties need to be loaded into the store before the component is rendered to the DOM, because all three sections of the page depend upon those values. So the lifecycle method that finally resolved the issue was before update, placed in the parent component of the components to be prefetched. The closest equivalent to before update in React is the seldom used get derived state from props. And the critical piece here, aside from the choice of lifecycle method, is its placement in the parent component slug, which makes it possible to load data dynamically based on a route parameter. Reverse engineering an application reveals a lot of the methods and approaches that are successful when working with its languages. You should have also seen some of the ways in which Svender served as a stress test, particularly for SvelteKit. These sorts of experiments are critical to Kit's development and help bring it closer to the much anticipated version 1 launch. So what's the goal of using Svender? To generate data visualizations quickly that look the way you want and can easily be integrated into a Svelte application. Svender is intended to save developers time by enabling them to build charts or chart prototypes rapidly with predictable and performant results. Maybe you have an internal site with a dashboard to track product or site metrics. Or maybe you have a user-facing application and you want to drop in a slick chart to clarify your message and improve UI. It could also be used by non-programmers, design and product teams, journalists, etc., to mock up data visualizations and improve collaborations with software engineers. Svender could even be appropriate for somewhat more complicated use cases, given how much more intuitive it is to customize the Svelte code it provides. Svender is open source, and the more people that contribute, the better it will be. One of the best things about working with Svelte is getting to interact with its vibrant community. If you, yes, you, add further customizations to a Svender chart or build a chart component for Svelte, please submit a pull request to Svender's GitHub repo. Similarly, if you see anything not working or you want to request a chart or feature, open an issue. But what about WYSIWYG? There are a few philosophical motivations behind Svelte that I believe are going to be extremely significant in the future of web development. One, programmers should be able to devote the largest portion of their time to the creative aspects of web development, not the implementation details. Two, the barrier to entry for interactive web development should be as low as possible. And three, web applications should be fast by default. These can all fit under one umbrella goal: empower designers. Rich recently shared his long-term vision for the future of Svelte. If possible, he said he'd like to create a WYSIWYG environment for building full-stack applications. He is not envisioning something like no-code, which he believes abstracts away too much of the process. He's thinking of an inclusive interface that allows people to participate in the web development process without downloading VS Code. This is an incredibly illuminating, inspiring insight, and it speaks directly to the motivation behind Svender. Building interactive web applications is a specialized skill. But why is that? The challenge should revolve around creativity, not logistics. In many ways, web development has actually become more approachable over the past 20+ years. Now, for example, you don't have to worry about how your code is going to look in one browser versus another. Rest in peace, Internet Explorer. You don't have to maintain a physical server. You don't need to learn any languages other than JavaScript, HTML, and CSS. Svelte itself is already a giant leap in this direction. It's so much easier to learn, write, and maintain. Svelte shines in many instances, not just for data viz, but data viz makes it especially clear how straightforward interactive web development can be. Now that Rich is at Vercel working full-time on Svelte and SvelteKit, we should be even more enthusiastic for the future of web development. React brought a paradigm shift that transformed the way in which we write front-end code. At their core, frameworks are a state of mind, a way of thinking about how code works. This directly informs our understanding of what our code can do. It's no surprise, then, that React has been pivotal in transforming the web to be more interactive. React showed us what was possible by showing us how to achieve it. Svelte refines React's paradigm by simplifying its approach, by making reactivity explicit and eliminating the virtual DOM, by building on its strengths of modularization and declarative style, and by mitigating its weaknesses, by reducing build size and other inefficiencies. In terms of implementation, Svelte, and perhaps even more so Kit, is radical. But the developer experience isn't radically different yet. It's a vast improvement over the tediousness of optimizing React applications by telling the framework how to do its job rather than simply trusting that it will. And true reactivity is a significant innovation, both in terms of performance and in terms of empowering designers. But isn't the process of modularizing code fundamentally about implementation, not imagination? What if we could just tell the computer what we want our website to look like and what we want it to do, and let the computer figure out how best to achieve our vision? As long as we're building interactive applications out of components, we're still living in React's paradigm. But if our WYSIWYG goals come to fruition, that will be a true paradigm shift. Thank you all for your attention. At this point, I'm excited to take any and all questions you may have.
I'm started designing websites and applications, or I guess sites, we'd call them, back in the mid 90s. I got horribly out of date through the aughts and beyond. So that's why I'm kind of with Codesmith at the moment, getting more modernized in the web world, as I'm getting more familiar with frameworks of various technologies and whatnot. I am having a bit of difficulty understanding Svelte's role, because the demonstrations you were giving us were predominantly sort of in literal graphing, not to be conflated, of course, with GraphQL, which just has a similarity by name, but as a sort of meta framework in a sense.
Right.
Is Svelte, in a sense, like for visualizations of data, that's its primary, the ease of, rendering server side or client side, hydrating on the client side, giving you that full customizability, or is there more to it? I ask too because you mentioned that the founder at Vercel, who also created, I think, Next.js, which is a React framework, they seem to be like all about the frameworks. So I just sort of wanted to check in on my understanding of that.
Absolutely. Great questions, great observations. You're exactly right, in that Svelte is incredibly well suited to data visualization. And you can clearly see when you're working with data viz, the advantages, just because of the sort of nature of the interactivity, the amount of rendering, the sort of, a lot of sort of small graphical components that can come in and out of the page, and sort of so it's not surprising in a sense that you've seen graphics design teams in major newsrooms embrace Svelte first. But broadly speaking, Svelte is a framework just like React or Vue or Angular. It's capable of doing any of the same things. I think one of the issues, one of the reasons that you don't see it being embraced as much yet, is that SvelteKit isn't at stable release yet. And it's, having moved from beta to release candidate last week is a huge step. When SvelteKit is stable, because there are a lot of companies that are interested, but they don't want to start building something in a framework that's not at stable release. Understandably, because just in the past few months, there were a whole host of breaking changes that would require significantly reworking your code base, and that's not something that a lot of companies have the bandwidth for. So once SvelteKit is at stable release, such that you can really build full stack Svelte applications, I think you'll see broader adoption, and we'll have more examples of sort of where Svelte shines. But in terms of its performance metrics, it's faster than React more or less across the board. It just it's that last piece, SvelteKit, that I think is going to need to come into play before we see broad adoption.
Thank you. And to sort of double question, this is my actual question now that I've confirmed my understanding is somewhat clear. Is Svelte necessarily an end-to-end, like your front end and your back end need to be all Svelte, or can it plug into sort of different frameworks and technologies?
Yeah, it's certainly compatible with other backends. You could use it with anything. There are some advantages to using it with SvelteKit, at least in theory, once SvelteKit arrives. Chief among them, the fact that if you're familiar with Svelte, you'll find Kit to be also very familiar. And so it saves you the trouble of having to learn something radically different. But you can absolutely use Svelte, with a different backend framework.
Thank you very much.
Yep, absolutely. Rami.
Yeah, thanks, James, for that very informative and wonderful presentation. I have a question. So Svelte, it seems like a really amazing idea in sort of visualizing a lot of like the React framework and whatnot. I wonder for Next.js, it is one of the biggest, most up and coming according to the Stack Overflow survey in 2022, and one of the top most wanted meta framework in React. Do you see a niche where Svelte can come in and sort of like answer that? We're providing visualization for developers in Next.js. Do you see some sort of like transition into Next.js? Or like what's on your mind in terms of that?
Yeah, I mean, having Vercel hire Rich Harris presents a lot of great questions, none of which they've understandably chosen to answer because they have all sorts of plans and they'd like to surprise us. I think it'll be interesting to see when Kit is at stable release, sort of how things unfold. I think Rich Harris has talked on numerous occasions about he would rather have a smaller group of users that are really passionate about using Svelte than a larger group of users that tolerate it. And I think this goes to some of the ideology. I mean, React isn't going anywhere in the immediate future. It's used in 80% of professional code bases, and it's broadly understood. It's a sort of common language that the developers can use, which is hugely valuable. But it does have significant shortcomings, and things don't tend to last for a very long time in the web development world. We're coming up on 10 years for React, so I'd be surprised if React is still as dominant in 5 years. Will that be Svelte, or will it be another framework that's been inspired by Svelte? It is tough to say. It's tough to say, but I think Next is obviously a hugely valuable tool in terms of bringing some server-side rendering to the React party. But I think it's always going to be a heavier lift to try to get React to do the things that Svelte and other more modern frameworks just do inherently.
Gotcha. And thank you so much.
Yeah, thanks for the question. Michael, what's on your mind?
Yeah. So first of all, I just wanted to thank you for the wonderful tech talk. But I guess as for my question, I'm just wondering, obviously React is still the big player, like you mentioned that a couple of times already. But when it comes to Svelte adoption, do you think there are still any barriers that are just preventing people from jumping on? Because obviously Svelte is going to have much higher performance overall, but do you think there are any barriers as far as like developer experience or just any pain points when it comes to actually developing a Svelte app that might turn someone away? From what I understand, the Svelte team is more interested or I guess more willing to throw away previous work if they don't think it's the right abstraction or if it just doesn't work. But do you think that just makes people a little bit more gun shy?
Yeah, I mean, it's a great question. I would like to think that Svelte version 3, which came out in 2019, is kind of the version of Svelte that's going to be Svelte moving forward. You know, and with Kit, there are no more planned breaking changes. That's sort of the meaning of the announcement, that it's moved into stable into release candidate phase. I think there are some things though that Svelte and especially SvelteKit need to improve on. And I think a lot of those sort of center around error handling and the sort of edge cases that you encounter once you start putting applications under heavy use. You know, there are just things that are really hard to anticipate about frameworks like this, building a framework, especially on the back end. And so it's sort of you know, a cycle that can go either way, right? Because people don't want to necessarily embrace it because they're not sure how it's going to work. But the way that it works depends upon having users that then, you know, share issues that can be resolved. So, you know, I'll be curious to see. I'll be curious to see because I do believe that the lack of a stable release backend counterpart is the number one issue. Although a close second would be tooling. You know, the people. I mean, it's a love-hate relationship because people are used to the React tooling and they appreciate that it's a wide ecosystem. But also, you know, some people would rather not have to reach for 10 additional tools and libraries in addition to their framework just to build the application. So, you know, I think in both cases it really comes down to adoption. You know, and my hope is that with Rich being at Vercel now, I mean, you know, before he was at Vercel, there was nobody working on this framework full time, whereas React has, you know, a team at Meta that's been working on this for a decade plus, since it was, you know, an internal tool first. So yeah, I think it's a great question. I think you know, the proof will be in the doing.
Okay, thank you. Yeah, because I guess for a little bit of context, I was actually looking at some Vercel job postings recently, and I did see that they were actually hiring content engineers, as in people who are software engineers but write documentation for other people, but it was specifically for Svelte. So it does seem like they are willing to put a little bit more behind that now that Rich is on board, and like there's a lot more momentum going.
Yeah, absolutely. It's a great. I mean, it's an exciting time, and you know, Svelte has an incredible tutorial. The onboarding experience for Svelte is just phenomenal. For Kit, not so much. For Kit, they don't have the tutorial yet. So I'm sure they're looking for people to come in and help put that together and really, you know, make that onboarding as seamless as possible.
Thank you.
Fantastic. I don't know if there are any questions in the chat that I should look at. Yes, we did. We all asked Jeeves so many questions. All right. Any other questions?
I got one real quick.
Sure.
how did you go about doing your market research and down selecting to your project in particular?
Great question. It's always tough to sort of find a niche. We were working on a tight schedule. We knew we had a limited amount of time to build the product. We had a small team, 4 engineers. We had a month to build the tool. So feasibility was a major consideration. We'd all worked with some of the React tooling in this space, like Recharts and Nevo, and we were all excited about Svelte. And the Svelte community is incredibly vibrant, as I said, and they communicate a lot. The Discord server, I think, is coming up on 50,000 members now, and they were more than happy to talk with us about what sort of tool would be useful. Reddit threads and this and that, and ultimately, it just seemed like a great fit given the time we had.
Thank you.
Yeah. Well, it's been an absolute pleasure. Thank you all for coming, and we will send out the slides. I'll make sure that those are shared, and yeah, hope to see you next time.